Hi listeners, you are welcome to the continuation of our online tutorial class from your favorite student ScoreBooster, your online tutorial provider on JAMB, WAEC, NECO and NAPTIP exam. For today's lecture, we shall be discussing energy. I am Bangbade. Before we proceed, we need to consider the learning outcomes of this particular presentation, which goes thus. At the end of this presentation, listeners should be able to define energy. Listeners are also expected to be able to state the forms of energy. They should also be able to differentiate between kinetic and potential energy. They should also be able to explain the interconversion of the kinetic and potential energy. And lastly, they should be able to solve relevant UTME questions relating to kinetic and potential energy. Now on to energy. Energy is the ability or capacity to do work. Energy is the ability or capacity to do work. Then we have various forms of energy, which include electrical energy, light energy, heat energy, sound energy, mechanical energy, which comprises of kinetic and potential energy. We also have solar energy and so on. But for the purpose of this presentation, we shall be focusing on the two forms of mechanical energy, which are the kinetic and potential energy. Now on to kinetic energy. By kinetic energy, usually represented by Ke, we mean the energy acquired by a body due to motion. It is the energy of an object in motion. Its unit is joule. Mathematically, kinetic energy Ke equals half mv square. Ke equals half mv square, where Ke is kinetic energy in joule, m is mass in kilogram, while v is velocity in meter per second. Now on to potential energy. By potential energy P, we mean the energy acquired by an object or a body by virtue of its position or state. I repeat, potential energy Pe is the energy acquired by a body by virtue of its position or state. Then we have what we call gravitational potential energy. Gravitational potential energy Pe is the potential energy possessed by a body of mass m, which is held at height h above the ground. I repeat, gravitational potential energy Pe is the potential energy possessed by a body of mass m, which is held at height h above the ground level. Mathematically, potential energy Pe is equal to mgh. Pe equals mgh. That's product of mass, acceleration, and height. P in this case means potential energy in joule, m is mass in kilogram, yh is height in meter, and g equals acceleration due to gravity in meter per second scale. Now, having understood the meaning of kinetic and potential energy, the next thing to consider is the kinetic energy potential energy conversion. I mean KEPE conversion. Now, we're to note that a mass m, which is thrown vertically upward with an initial velocity u and climbs to height h has the following values of energy associated with it. So it's going to have the two energy, the kinetic energy and the gravitational potential energy. Now let's consider the ground level. At the ground level, the kinetic energy will be half mu square. Half mu square. Y is not going to have any potential energy, so the gravitational potential energy will be 0. I repeat, at the ground level, the object is going to have kinetic energy which is equal to half mu square, while the gravitational potential energy will be 0. While at height h, the object is not going to have any kinetic energy, so the kinetic energy will be 0, while the potential energy will be maximum, and that will be equal to mgh. So in terms of the total under the ground, the total energy will be the kinetic energy which is half mu square plus 0 value of gravitational potential energy, while the total of the energy at height h will be equal to mgh since the kinetic energy is 0. Now, an example of kinetic energy potential energy conversion can be found in simple pendulum and helical spring. Now let's consider the diagram here, which is that of simple pendulum. So after tilting the pendulum from point B, it tends to move towards A, then from A moves through B back to C. So as it moves towards A and C, the velocity will be reducing towards 0 up to when it will be 0. That's when the bulb will stop. Then when it starts moving back, the velocity increases again. So at point A and C, the velocity is 0, meaning that the value of kinetic energy will be 0 there, while the potential energy will be maximum. But if you look at B, we have maximum velocity there. That means the kinetic energy will be maximum at B, while the potential energy will be 0. Now, the table below summarize the fates of the potential and kinetic energy. At position B, which is equilibrium, the potential energy equals 0, while the kinetic energy is maximum, and that will be equal to half mv square. That is for the simple pendulum. While at point A and C, the potential energy will be maximum, which is equal to mgh, while the kinetic energy is 0. Similarly, in helical string, at point B, the potential energy will be 0, while the kinetic energy will be half mv square. Then at point A and C, the potential energy will be given as half ks square, while kinetic energy is 0. Now, having understood the interconversion of kinetic and potential energy, the next thing we need to consider is the law of conservation of energy. Law of conservation of energy states that energy can neither be created nor destroyed, but can be converted from one form to another. I repeat, law of conservation of energy states that energy can neither be created nor destroyed, but can be converted from one form to another. If you follow this rule, that means kinetic energy can be converted into potential energy. Hence, Ke will be equal to Pe. Now, let's recall that Ke equals half mv square, while Pe is equal to mgh. Therefore, half mv square equals mgh. In both, we have m. We can cut it out. When we cut out m, then we'll be left with half v square equals dh. Then we can cross multiply. When we cross multiply, we get phi square equals 2gh. Then you make phi the subject by square rooting both sides, and that will give us phi equals 2gh. So we have to take note of this. Phi equals 2gh, as we can need it later. Now on to sample questions from the UTME. And the first question we shall be considering comes from 1982, number 3. And the question goes thus: a mango fruit drops from a branch 10 meters above the ground. Just hitting the ground, its velocity is dash. Then you are given in brackets g equals 10 meters per second square. You are given option A to be 10 root 2 meter per second. Option B is 10 over root 2 meter per second. Option C is 100 meter per second, while option D is 5 root 2 meter per second. Now on to solution. The first thing is to write out the given parameters. And from the question you are given height h, which is 10 meter. Then we are given acceleration due to gravity g, which is 10 meter per second square. Then they ask us to find phi. Phi is unknown. Now, let's recall that potential energy can be converted to kinetic energy. Hence, P equals Ke can be equal to Ke. That is law of conservation of energy. Then from there, we can prove phi equals root 2gh, just as we just did under the law of conservation of energy. Then when you apply the formula, phi will be equal to root of 2 times g, which is 10, then times h, which is also 10. That will give us root of 200, and root 200 can be, give us 10 root 2 meter per second, making option A the correct answer for this question. Now the next question we shall be considering comes from 1994, number 9, and the question goes thus: an object of mass 50 kg is released from a height of 2 meters. Find the kinetic energy just before it strikes the ground. You are given option A to be 250 joule, option B to be 1000 joule, option C to be 10,000 joule, while option D is 100,000 joule. Now on to solution. The first thing is to write out the given parameters. That's the first step. And from the question you are given mass M to be 50 kg. Then h, that is height h equals 2 meter. While acceleration due to gravity g is a constant and is always equal to 10 meter per second square. Now using the law of conservation of energy, then we can say kinetic energy K equals potential energy PE, which is equal to mgh. So we can find kinetic energy from potential energy parameters. Therefore, we can arrive at our kinetic energy K equals mgh. So, and when we substitute for the parameters, our Ke will be m, which is 50 kg, times g, which is 10 meter per second square, then times h, which is 2 meter. So 50 times 10 will be 500, then 500 times 2 is 1000 joule, making option B to be the answer for this question. The next question we shall be considering comes from 1997, number 12, and the question goes thus: an object of mass 100 grams projected vertically upward from the ground level has a velocity of 20 meters per second at a height of 10 meters. Calculate its initial kinetic energy at the ground level. Then we are given option A to be 10 joule, option B is 20 joule, option C is 30 joule, while option D is 50 joule. Then you are given acceleration due to gravity g equals 10 meter per second square in bracket. Now on to solution. The first thing is to write out the given parameters. And from the question we are given mass m to be 100 grams. We need to convert this to kilogram by dividing it by 1000. And that will give us 100 divided by 1000 will be 0.1 kilogram. Also, we are given velocity phi to be 20 meters per second from the question. Likewise, we are given height h to be 10 meters, and lastly, acceleration due to gravity g to be 10 meters per second square. Now, the question asks us to calculate initial kinetic energy. For us to get initial kinetic energy, we need to get initial velocity, because we use initial velocity to calculate initial kinetic energy. And we have to recall from our previous work, that is motion under gravity, the equation connecting initial velocity and final velocity, which is phi square equals u square minus 2gh. So when we substitute for this, phi square will be 20 square equals u square, that is the unknown, minus 2 into g, which is 10, then into h, which is also 10. Of course, 20 square will give us 400, which is now equal to u square minus 2 times 10 times 10 will be 200. Then we can make u square the subject by transferring minus 200 to the other side, and that will give us u square equals 400 plus 200, making 600. So our u square equals 600. Then we can now proceed to the formula of kinetic energy, which is half m phi half mu square. So if you substitute for this, that will be half into m, which is 0.1 kilogram, then times u square, which is 600. So 2 can cause 600 to 300. So our initial velocity will be 0.1 times 300, and that will give us 30 joule, making option C the correct answer for this question. Now on to practice questions from UTME. You can practice this on your own, and the first question we present here comes from 1999, number 3, and the question says an object of mass 0.1 kilogram is thrown vertically upward with a speed of 10 meters per second from the top of a tower 10 meters high. Neglecting air resistance, its total energy before hitting the ground is dash. So the expected answer here is 15 joule. Then the second question we are presenting for your own practice comes from 2013, number 9, and the question goes thus: an object is moving with velocity of 5 meters per second. At what height must the object situated to have a potential equal in value to kinetic energy of the moving body? Then you are given option A to be 25 meters, option B is 20 meters, option C is 1.3 meters, while the option D is 1 meter. Expected answer here will be 1.25, which is approximately 1.3. That is option C. So we are to use the law of conservation of energy in this second one, taking note that your PE will be equal to KE. Of course, they've told you in the question. Now, our next video will be on work done with sample questions and solutions from the UTME. So, I urge you to please subscribe to our YouTube channel, like and share our videos, as we promise to be bringing you more interesting presentations on subjects relating to UTME exam. Thank you.